You've probably gotten tired of typing the same commands over and over again to compile your code. At first it's not so bad, but the more flags you need and the more options you have, the worse things get. Make is a program that's designed to automate the compilation of software to make this process a whole lot easier. Okay, so here we are in a directory for Homework 7. And you'll see that 2 of the programs actually live in this project called Activity, in this subfolder. So we have problem1.c and problem2.c. Problem1.c is going to get compiled to produce a program called log, and problem2.c will get compiled to produce a program called summarize. So normally I would write something like gcc problem1.c -o log, and I would compile my code that way. But let's write a makefile to do this. So we'll go ahead and edit the makefile. It's always makefile with a capital M. And here we are in this new file. Our makefile will consist of a series of recipes. So in this case, we'll define a new recipe to produce the program called log. And to produce log, we will run gcc problem1.c -o log. I make sure right at the beginning here, this is supposed to be a tab. So if you've got Vim set up to do spaces instead of tabs or something, make sure this really is a real tab and not just a bunch of spaces. Okay, let's save this file. And now we can run make log. This tells us that log is already up to date because the file log already exists. So let's just remove it and try again. Here it runs gcc, produces the file log, and we can see it here. So one feature of make is that it only rebuilds the output files when the input files have changed. But to do that, it needs to actually know what the input files are. So let's go back to our make file. So we can say that log depends on problem1.c. So anytime we update problem1.c, then we need to rebuild log. Now we can try make log. And it says log is already up to date. The edit timestamp on log is newer than the edit timestamp on problem1.c. So log is as up to date as it needs to be. But now if we go and edit problem1.c, and we do something even, such as adding a comment, now problem1.c has been updated, and we'll go ahead and try making log again. And now this time make recognizes that we've updated problem1.c and we need to recompile it. And so it will do that for us. Okay, easy enough. Let's go ahead and add the second project. So we have log. There's going to be the summarize program, which will depend on problem2.c. And we'll build that by running gcc with problem2.c and producing a binary called summarize. And we can say make summarize, and it will build that program. So now let's say we want to add a compilation flag to all of the programs that we're going to compile. So let's go ahead and edit the makefile again. Say we want to compile them all with C99 instead of the default. Okay, so we can just write a standard equals GNU 99 to use the GCC C99 standard, and we can add that to every recipe we wanted. But a better solution is to use a variable for this. So I'm going to cut this out and we'll put it at the top. We can define a new variable, so let's call it cflags, and define cflags to be -standard equals GNU 99. Now I can use that variable by using the $sign and then wrapping it in parentheses. And then I can do that again down here. And now anything I add to cflags, so if I wanted to add debugging symbols or specify warnings or errors or something like that, I could do that once and then it would apply to all of the builds that I have here. The next thing we might want to do is have one command that just compiles everything. So if you have multiple build targets, in this case we're making multiple different things, it might be nice to have one command that just builds everything. So we can do that with our make file. Let's define a new recipe. There's a special recipe called all, and we'll just say that it depends on log and summarize. And if I just type make without anything attached to it, it'll run make all. In this case, it says there's nothing to be done for all because both of those binaries already exist. But if I were to remove the log and summarize and run make again, notice that it compiles both of these in this case. One last thing, you might want some way to clean up all the binary files. So before you do a git commit, perhaps you might want to just make sure you delete all the binaries, or you have some way to just clean everything and rebuild. So we might add a clean target. And here we can just remove log and summarize as a quick way to clean up all the output files. We do make clean, and those files are gone. If I just run make, again, it rebuilds those files. So I have definitely just scratched the surface of make. There are many pages of documentation and many hours of practice and things to learn with make. But this should be enough to get you started and help you through this course. You'll actually be required for homework 7 to write your own make file, both for this problem and for the other problems. And in the future, you'll be writing lots of make files to compile all your code.